For the second topic, we're graphing a parabola, but this isn't in this, let me show you the forms that we want them to be in. Remember this orange or green highlighted forms that we can graph by just reading the vertex and plugging in numbers to find additional points. So our goal for these problems in topic 2 is to rewrite it so that they are in a form, well, I want to call them vertex form because we can easily identify the vertex. But look, we notice that y is getting squared. So I want to rewrite that equation so that it becomes this form. Okay, we want to rewrite it so that we have x equals a times y minus k squared plus h. Okay, so what we're going to do is keep all the y's to the left. Okay, we're going to keep all the y's on the left. So I'll keep them here. But let's move anything that doesn't have y to the right-hand side. Okay, so I'll have 2y squared plus 12y equals positive x and negative 14. Now we're going to complete the square on the left-hand side, but you notice that we have 2 in front of it, y squared, right? So let us factor out that 2 to the front. So that 2y squared will turn into y squared, and 12y will turn into 6y. Now, I'm going to give a little room over here, because now we're about to think about what number we should add to this y squared plus 6y. Remember, as always, half of that middle number, so it's half of 6 squared. Half of 6 is 3, and 3 squared is 9. So I am going to be adding 9 inside that parenthesis, okay? Now watch. Even though we added 9 inside this parenthesis, if you look at the entire left-hand side, we are really multiplying this 2 by 9. So to the left-hand side, we are adding 2 times 9, 18. So that's what I'm going to add to the right-hand side. So the right side was x minus 14, but I will be adding 18 to that right side, okay? It's a very common mistake that people will just add 9 to both sides, but no, we have to distribute that 2 times 9 to add 18 to both sides. So let's factor that trinomial. I'm going to get y plus 3 squared, and all that equals what? X plus 4. Okay, we're almost done. Okay, we're almost done. I am going to move this 4 back to the left side. Then we have 2 times y plus 3 squared minus 4. And instead of putting equal x there, let me just put that x over here, okay? And now I'm going to copy that form that we wanted to get it into. Now, does it look the same? It really does, right? So look, we got x on the left-hand side. A is 2. That's positive. So we will be opening to the right-hand side. Okay, we're going to go to the right side. Y minus k is what we wanted, and we have y plus 3 inside. And outside we have minus 4 for h. So we got it in the right form. Let's read the center from this first, okay? The center is going to be hk. The x coordinate of the vertex. Well, for this one, it's actually easy to tell the y coordinate of the vertex first, okay? What's the number being subtracted from y? Well, it says y plus 3, right? So guess what? The y coordinate of the vertex is negative 3. Now, I just need to read the x coordinate of the vertex now, and you notice that we got negative 4 there, and that is the h value. So the center is at negative 4, negative 3. Let's plot that. So go 4 to the left and down 3. What I'm going to do is I'm going to sketch a dotted horizontal line at y equals negative 3, because we're going to have the axis of symmetry right there, okay? After that, we just need to plot a couple points, okay? So this function, not a function, this parabola will take y as its input, and then x can be calculated by doing 2 times y plus 3 squared minus 4. So I have a y value of negative 3. Okay, so when we plugged in negative 3, the y value of negative 3, we know the x will be negative 4. Okay, you can confirm this. If you want to actually plug it in to see if that's true, you'll get it. Okay, now I am going to pick another point. How about I plug in negative 2 this time? What if I plug in negative 2 for the y value? Then I will get 2 times negative 2 plus 3 squared minus 4. That is 2 times 1 squared minus 4. So we will get the x value of negative 2. So we will plot negative 2, negative 2. So go 2 to the left, down 2. Here's the point. Now look, if I get this purple dot that is one above from the axis of symmetry, we know we're going to have another purple dot, one below the axis of symmetry. Okay, so I got 2 points, well, 3 points, but I think I'm going to get one more. Okay, let me get one more. What will happen if I plug in negative 1 into this function? Or I keep calling it function, I apologize. This is not a function, this is just a parabola. This is a relation. So if I plug in negative 1 in there, I will get 2 times negative 1 plus 3 squared minus 4. That is 2 times 2 squared minus 4. And that gives us what? 8, 4. So we know that when x is positive 4, y value is negative 1. Okay, so go plot 4, negative 1 here. 4 to the right, down 1. So there's that orange dot right there. But if I have a dot that is 2 above from the axis of symmetry, I know I'm going to get another one down here. So I think that's enough. We got enough dots. Okay, I'm going to connect these to sketch a parabola that's opening to the right. Okay, so for these types of problems, you will have to do some rewriting first. After that, identify the center. I'm sorry, I did not mean to call it center. See guys, we've been doing too many ellipse, center, and hyperbola. I keep calling it the center. We found the vertex, okay? The vertex, after finding the vertex, you can find maybe just 2 more points and then use the axis of symmetry line to plot 2 additional points, okay?